was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exam to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary. That is, the students' doubts gets cleared and everything else. So today I came down to the XLR office like to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that
Very good evening, Amar. Can we start now? Hello?
Yes, sir.
Okay, great. Okay, guys. So very good evening, everyone, and welcome to the session. Today we are going to talk about the trees. Okay, in that we'll talk about trees, binary tree, tree traversal, and BST, binary search tree. Okay, so these are the topics we are going to discuss over here. Can you guys once confirm everyone? Am I audible to you all? Can you hear me clearly, everyone? Okay, great, great. Thank you for the response. Okay, so can anyone elaborate for me? What do you mean by tree? Can you define a tree for me? Yes, can you define a tree for me, guys? Guys, can you please wait for 2 minutes? Hello, everyone. Can you just give me a 2 minutes out, guys? Hello? Please wait for 2 minutes. Okay, guys. So very sorry, guys, for that. So let's start with the tree. Okay. So obviously, tree is a data structure. Okay. So tree is a non-linear hierarchical data structure used to organize data in a parent-child relationship. So we are going to organize the data in a parent-child relationship, guys. Okay. So unlike array or linked list, which are linear, a tree branch into the multiple path. That's why it is called as a non-linear data structure. So you can see the one example over here, organizational hierarchy. So C will be the CEO will be there. Under that, multiple managers will be there. Under manager, multiple employees will be there. Okay. So each employee report to one manager. Okay. And then it is going to form the tree. Okay. So that is how we can define the tree over here. Okay. For now, it's not in plan. Sorry, Amar, can you please, you have sent the message for whom? To me? Okay, maybe for someone else, no issues. Okay. So, guys, real world application of the trees are like file system. So folder and file hierarchy. Okay, companies like employee hierarchy and all, right? Then colleges, so department, classes, student. So in banking, account categories. Okay. Then HTML, XML, you have a DOM tree. In machine learning, decision tree, classifier algorithm. So there are many examples of tree are there. Okay. So computer folder is the best example of tree data structure. So every folder can contain multiple subfolder. So there are certain terminologies which we need to understand before going ahead. Okay. So like root. So two topmost node will be there. Okay. So that is called as a root. Then parent node will be there. This A is whichever node is having a children, it will become a parent node. So A is also parent, B is also parent, C is also parent. Okay. But D, E, F, G are not parent. Then child node connected below parent. So B is child, C is child, D is child, E is child, F is child, G is child. Okay. And then the leaf node. So node with a no children. So obviously D, E, F, G are not having any children node. So that is a leaf node. Then sibling node having a same parent. Okay. So D and E are sibling because they have a B. B and C also sibling because A is a parent. Right. Then ages connection between the nodes. Height longest path from root to leaf node. Okay. So A to G is the height of the tree. Okay. Then level distance from root. So from the distance to root and number of children, it is a degree. Okay. So all these things are, I hope most of you are aware of that. Okay. So you understood that. We'll discuss furthermore. But before that, we'll see how we can create a binary tree representation in a Java. Okay. So if you remember, we talk about in linked list about the node. So in similar pattern, we can create a node tree over here. So wait a minute, tree node we will create here. I'm sorry. Should open a notepad. Okay, so you guys can observe this simple code for representing the node into the tree, right? So first of all, we are creating a class called as a node. In that data, one variable, node left for left side, node right for right side, and then we'll create a constructor node in data, and this dot data will assign the data, and left right will assign a null because individual node we are going to create. Is that okay, guys? This code for creating an individual node in a tree. Hello, everyone. Okay, great. Good. Let's move ahead now. So creating a binary tree. Okay, so we'll see how we can create a binary tree into the Java using Java code and all. Okay, so wait a minute. What do you mean by binary tree, guys? Can anyone define a binary tree for me? What do you mean by binary tree? Hello, what do you mean by binary tree, guys? What do you mean by binary tree, guys? Am I audible, guys? Can you hear me? Hello? Yes, so what do you mean by binary tree? Having at most two children, correct? A binary tree is a type of tree which is each node can have at most is very important, two children, a left child and right child. So we are going to create that over here. Very good. Okay, so you guys can see here, first of all, we are creating a class called as a binary tree. In that we'll create a node, static class node, int data, node left, right, and then we'll only assign the data to this current class variable data. Okay, and then in main method we'll call that node. So node root is equal to new node 10, then root dot left 20, root dot right 30, and then root left dot left 40, root left dot right 50. Okay, so you can see here at most two children are there for each tree, so that's why it is called as a binary. Is that okay, guys, for you all? Binary tree, how we can create a binary tree in Java? Yes, everyone. Correct, correct. So is that okay? Have you understood the Java code for creating a binary tree? Okay, great. So can you please practice this? You have a 10 minutes. Can you practice this, everyone? Hello? Please reply. Can you practice this? Please practice it. Guys, if I make your disconnect, then I will connect with the another network. Okay, but I am there only. Wait, please practice this. Okay, guys, very good. So I hope everyone completed that. Good. So this is how we can represent the binary tree. So there are types of binary tree, full binary tree and all. Okay. So complete binary tree, perfect binary tree. Okay. So I will request you, you can revise those things over here, right? So we are going to see how we can insert into the binary search tree over here. Okay. So for that, we'll see the one minute, huh? Okay, good. So we'll see this Java program over here. Okay, should I explain these types of binary tree, guys, before that going ahead? Full binary tree and all. Okay, see here. So full binary tree, every node has either 0 children or 2 children. Okay, so you can see here A has 2, B has 2, but C has 0. So that is called as a full binary tree. Okay, and then complete binary tree. So all level are completely filled except possibly the last one. Okay, so all layer are full, completely filled. So you can say which is filled from left to right. So one is filled, two is filled, three, but last one is not. But still we can say completely filled. So that is called as a completely filled. Perfect binary tree, every internal node has two children and all leaves are at the same level. Okay. So everyone is having a two children, all same level. So that is called as the perfect binary tree. Okay. Skew tree, only one child exists for every node. That is called as a skew. So this is a left skew tree. This is a right skew tree. Is that okay, guys? Types of tree. Hello, everyone. Types of binary tree. Okay, great. Now we'll talk about the BST. So obviously we'll go in more detail, but still binary search tree follow these rules. So left subtree contain smaller values. So this is first rule. Left side will contain the smaller values. Right subtree will contain the larger value. Yes, guys, am I audible to you all? Hello, everyone. Can you hear me? Can you hear me? Please reply. Okay, great. Okay, so I was talking about the binary search tree over here, guys. So binary search tree follow these rules. Left subtree contains smaller value, right subtree contain larger value, and both left and right subtree are also binary search tree. Okay, so you can see here 50. So here 30. This left tree 20, smaller, right 40, bigger. Similar way on this side, 70 is bigger compared to the 30. Then all 60, smaller, 80, larger. Is that okay, guys? Binary search tree for everyone? Hello? Now we'll see that insertion. Obviously, we'll discuss more detail about the binary search tree also. So we'll see this example. So you can see here, we are creating a tree node, int data node left, right, okay. And then we'll create a constructor and pass the data to the current class variable. Then public class BST is there. So node insert. So node root and int value we are passing here. So if root is equal to 0 null, then directly return the new node value assigned to the root. If value is less than root dot data, then root dot left will call the insert on the left side. If value is else means greater, then we'll call on the right side. Can anyone tell me what concept is this? Calling function inside function. Calling function inside function. What it is called as? Recursion. Very good, guys. Very good. Okay. So this is how, and at last it is going to return the root. Okay. So this is just for inserting that. Okay. So what I want, you have to do this, but this is not complete program. you have to write a main method for this. Can you do that? Can you try to do that, guys? Hello. Okay, please complete that and then share it in chat box everyone. Please do it. See, I want to create the BST na. So for that insert method has created. To insert it value at left or right. Okay. Node on right or left. So you have to complete that code using the main method. Is you just need to add the main method and create a node. Is that okay? Prathamesh, please do it. Naina, I'm expecting the main method from you. You have to write down the main method, call these methods, insert method, and complete the code. I'm expecting the code from you guys. Just complete the code and share it in chat box. Yes, guys, please complete that code and share. Okay, you can do that later, no issue, even though we'll also do it. Okay, so now let's go ahead. So we'll talk about obviously we are going to in detail, little more detail about this. So binary tree will talk first. So already we have discussed what is binary tree and all, right? So there are two children are called left and right children. Okay, so nonlinear data structure, each node can contain at most two children. Okay, so company hierarchy and all examples are there. We already discussed that. So we directly go for the code. Okay, so we are going to create here. We already created binary tree. Have we created a binary tree? I think yes, right? Binary tree we created, right, guys? Hello, are you there, guys? Am I audible to you all? So full binary tree and all we have done, right? Okay. Okay. So guys, order traversal also will talk. So in order, listen, in order, first we'll visit a left, root, right. So please remember this left, root, right. Okay. And for code we'll see later on. First try to understand pre-order. So root, left, right. Okay. So in order is a left, root, right, LRR. Pre-order is a root, root, left, right. Okay. This sequence please remember or make a note. Post order, left, right, then root. Okay. So we are going to see, we'll see that bed first search and all. Okay. 1 minute. So we are going to see the binary tree example, working example over here. Okay, let me explain this first so you guys will get a good idea about that. 1 minute. So with insertion and all, we'll see. So program is going to be a bit lengthy, but I will explain each and everything. Okay. So we'll start from the main method. So in main method, if you see, we'll call the node. So we are creating a root node, passing the value 10. Then on root dot left, we'll call add the 20. Root dot right will add the 30. Then again root dot left 40. Root dot left dot right 50. Then again root dot right dot left 60. Root dot right 70. Okay, and then we are calling a method in order, pre-order, post-order. So we'll see how we have created all these methods. Till here, is it okay? Main method for everyone, guys. Then I will explain the methods which we have created in order. Okay. Now guys, here, first of all, we'll create a node. So I think everyone familiar with this. So in node, we'll declare the three variable data, left, right. Okay. And then we'll assign the data to the current class instance. Okay. Now we are going to create a first method called as a in order. So can anyone tell me the sequence of in order? Sequence of in order? Left, root, right, right? Okay. So you can see here, we'll create a function in order where we'll first check root equal to null. If it is null, then return. There is no need to do the in order. So we then will call a in order, and in that insert the root dot left, and then we'll go for root element, and then we'll go for again in order call, go for root dot right. So we are using a recursion. So every time it will call that in order. So left, then root, and then right. Is that okay, guys? In order. Hello. Is that okay? This function in order for everyone? Please reply, guys. Is this function okay for you all? Am I audible to you all? First of all, tell me, am I audible to you all clearly? Okay, great. Now pre-order, only sequence is going to change. So in if root equal to null, then it will return, or else first we'll go for root, then left, then right. Okay, it will call the pre-order one. Very simple. Post order also again, we'll check root equal to null, and then post order left will go, right will go, and then root will go. Okay, this is how we are going to perform the tree traversal in order, pre-order, post order. So guys, can you complete this? Can you practice this code, everyone? Yes. Yes, others. Can you practice this one? Please reply. Please practice this and then we will go ahead. Guys, if you are done with this, let me know, then I will scroll. Just let me know in a message to scroll up and down. Okay, I hope everyone done this. Great. Let's move ahead now. Okay, fine. Now, guys, we'll go for. So, tree traversal we already discussed over here, right? Okay, 1 minute. Okay, so three type are there: pre-order, in order, post order that we have seen. Okay, then breadth first search. Okay, it is also called as a level order. Visit node level by level. Okay, and the another depth first search. Imagine exploring the building instead of visiting every floor. Okay, so we'll see that. So your first explore one room completely, then return. This is DFS. Okay, so we'll talk about DFS and BFS first. Wait a minute. In order, pre-order already done. So you can see here, breadth first search is also called as a level order traversal. Instead of going deep, visit one level at a time. Okay. So we'll visit level 1, so 10, then level 2, 20, 30, then level 3, 40, 50, 60, 70, like that. Okay. So we'll see the level order program first over here, and then we will go ahead. Okay. Is that okay, guys? Can we see the level order over here? So, oh, wait a minute. 1 minute. Wait. In order, pre-order, we already done. Post order done. Okay. So in order, pre-order, we already done. So we'll just use the pre-order, post-order part. Okay. So if you want, you can skip or you can do that also. That's not a problem. Okay. It is up to you. So you can see here first we are creating a node. Okay, we are importing the java.util package for linked list and queue. Then we are creating a node, data left, right, then constructor. Pre-order already explained to you all guys, right? Is there any need to explain now pre-order, in order, and post order, guys? Please reply. Hello. Hello, guys. Am I audible? Am I audible? Can you hear me? Can you hear me, guys? Please reply. Not audible, guys. Okay, or no need to explain that. Okay. So you can see level order is there. So in level order, what we are going to first, if we'll check root equal to null. So if it is null, then we'll stop it there itself. But in case if it is not, then we'll create a queue. We'll implement the linked list. Okay, queue is an interface, linked list is a class. So we'll offer the queue dot offer, root will offer. And then while queue is empty, means if it is not empty, we'll simply create a object node current and queue dot pull method will call. Do you remember, guys, what is the use of pull method? What is the use of pull method? Yes, everyone. What is the use of pull method? Okay, the pull method is used to remove and return the first element, right? So that's what we are doing, and we are assigning to the current. So we then will print that current data, okay? And then if current dot left is not equal to null, then we'll say queue dot offer current dot left, okay? If not equal to null. And similar way, if current dot right is not equal to null, then go for right one. Current will be assigned to the right one. So we are going level by level. So first level will complete. So this will be complete. This will run till the time our queue is not empty. Okay, so like that. So then we will create a node object and then we'll add the element and call the method. Is it okay, guys? Can you try this one also? I know that in order and all. So just let me know to scroll down because you know you don't need a pre-order in order, but please follow the sequence. Can you do this? Okay, explain again. Sorry. So you can see here in order, post order we have done. So level order, we are just checking first if root equal to null, then it will return, or else we'll create a linked list. Okay, in that we'll first offer the root, and while queue is not empty, till that time this loop is going. So every time we are going to pull the element and put it into the current, and then we'll print that current data and we'll check current dot left not equal to null. Then inside of offer to the current to the left. If current dot right not equal to null, then offer current to the right. Is that okay now? Hello everyone. Can you try this one? You already have half of the code. You can quickly complete that and then we'll go ahead. So you just let me know while scrolling down. Just write a message, scroll down. I'll do that. Okay, 1 minute. Wait a minute, guys. Others, please wait. Let them complete. Soham, once you are done, let me know. Then I will scroll down. Okay. Yes, guys, everyone done till here. Hello. Hello, guys. Please reply. Okay, I'll wait. No issue. Yes, guys, done till here. Okay, great, guys. 1 minute. What is remaining? Okay, we'll talk about binary search tree. Okay, so what is binary search tree? So binary search tree is a special type of binary tree that follow the following rules. So every node has the at most two childrens. All values left subtree are smaller. We already discussed, but we are just discussing. And all value right to subtree if word comes before it, search it on left or else search it on right. Is it okay, guys? Binary search tree definition. Hello, everyone. Okay, fine. So we'll see the program for this also. We already discussed the rules. One minute. So I told you to complete that program. So that complete program I'm going to show over here now. 1 minute. Okay, so BST program I told you to complete, but no one has shared that with me. So I'm going to do it over here and show you. I'll explain you. So guys, you can observe here, first of all, we are going to create a node in that data left, right, and we'll pass the data to the current class variable. Okay. Then we are creating an insert function. This function I initially also have explained you. So static node insert will pass the node root and value. So if root is equal to null, we'll directly return the new node value. If if value is less than root dot data, then it will go for left side. We'll call the insert. If it is greater than value, then it will go on right side. Is that okay, guys? This function I already explained to you all. Hello. Insert function for BST binary search tree. Okay. After that, in order. So in order, the same code which we have discussed. So first left, then root, then right. Okay. And then we are going to discuss the search one. So if root equal to null, it will return false. Otherwise, we'll check if root dot data is equal to key, then return the root itself. If key is less than root dot data, then it will go for left side key. Okay, or else it will search on right side key. Okay, this is how we are going to search. If root key is less than root dot data, then obviously lesser amounts are on left side, and greater amount on right side. Is that okay, guys? Search function. Hello. Yes, guys. Is that fine? The search function. Okay. After that, guys, public void main. So we are going to node root null. We are assigning int values. We are assigning to that values, and we are using a for loop. So values into values, and we are calling the insert method. So one by one, we are inserting all these values. Okay, and then we'll call in order, and then we'll print the search the 60 and 90. Is it okay, guys? Main function also. Hello. Hello, everyone. Please reply. Can you do this one? Please do this. If you have any question also, feel free to ask. Please complete. Once you're done, let me know. Then, guys, I will scroll down. Okay. Yes, guys, if you are done till here, let me know. Then I will scroll down. Okay. Yes, guys, have you done till here? Can I scroll down? If you want, you can take a photos and you can try that after the session also. Can I scroll down, guys? Please take the photo of that and then you can complete that. Okay. Okay, great guys. If you have any question, query, please feel free to ask. If not, let me know, then we will wind up the session. Anyone, if any question, query, please feel free to ask. Please practice the tree related question also. And if not, let me know, then we will wind up the session. Yes, guys, if no more question, please let me know, then we will wind up the session. Hello, those who are listening me. Okay, Amar, I think there is no questions. Yes, Amar, can we wind up a session now? Hello, Amar. Yes, guys, can we wind up a session then? Hello. Okay, then. Amar, are you there?
Yes, sir.
Okay. Thank you, Amar. Good night.
Yeah, thank you,
Good
sir.
night, everyone.